5, 4, 3, 2.
Hello guys, this is Carla, your teacher, and I'm going to show you how to recognize the equation of an exponential function if you see it, if you see the sketch of the graph. So let's start by writing the general form of an exponential equation, and that general form should be something like y is equals to a elevated to the x minus h plus k, where the constant k make reference of how the graph is moved vertically, and the constant h is the movement, the horizontal movement. If h is negative, the graph will move to the right, and if h is positive, the graph will move to the left, as we have seen that in class. So let's start by the vertical movement, which is the most simple movement. In this case, the first thing to notice the vertical movement will be to analyze where the horizontal asymptote is. So you first have to obtain the horizontal asymptote. In this case, the horizontal asymptote is at y equals 0, so there is no vertical movement. So our x-axis is exactly in which it is, and then we move according to the new x-axis, or the horizontal movement. We move 1 unit up in order to see where my first critical point is. In this case, my first critical point is at 0. That means that there is no horizontal movement neither. So we have a graph or a function which is not moved, not vertical nor horizontal. And what is the value of y when x is 0? The value is 0, 1. That shows us that there is no horizontal movement. So the function will be something elevated to the x plus 0 plus 0. There is no vertical nor horizontal movement. The only thing that is missing is how to find the a, and we're going to find the a by placing the x value at 1 and counting 1, 2, 3, 4, 5. We have our intersection at 1 with 5. That means that the value of the base is 5. So it is 5 to the x, and that's it. That's the function. This was a very easy function because we don't have not horizontal or vertical movement. Let's do the second function. The second function, if we sketch the horizontal asymptote is at -4. So our function that should be y equals to a to the x minus h plus k, we will have that k, it is equals to 1, 2, 3, 4, -4. So we will have that y, it is going to be equals to x minus h minus 4, because we move according to the x-axis 4 units. Once we have our new horizontal asymptote, that will be like our x-axis, our new x-axis. We move 1 unit up, and we realize that the value of the function, when we move 1 unit up, the function intersects in these values. So we can assume that the graph is moved. How many units is moved? According to the original y-axis, is moved 3 units to the left. So this h is going to be positive 3 because the horizontal movement is opposite to the sign. So this will be a to the x plus 3 minus 4. The only thing that is missing is the a. So this is my new y-axis, and according to this new set of axes, this is 0, 1, so we're looking for 1. When x is 1 in my new horizontal, in my new x-axis, the value of y will be 2, and that's the base. Y, it is equals to 2 to the x plus 3 minus 4. So let's continue at the last, well, the other example. Again, we have to start by the general form of the exponential function, which is a to the x minus h plus k. So by obtaining first the horizontal asymptote, you can see that the horizontal asymptote is at 2. So this function will be a to the x minus h plus 2. Then, according to this horizontal asymptote, we move 1 unit up to see what is the first critical value that in a usual movement will be 0, 1. And that point gives you the idea of no vertical movement. So this will be a to the x minus 0 plus 2. So last thing we have to obtain is the constant or the base. So we move according to our new x-axis 1, and when x is 1, the value of y tends to be 1/2. That's why the graph is decreasing, because the value of the constant or the base is less than 1. Finally, our final function, it is a negative function, and we know that it's negative because instead of increasing, the function is decreasing, but you can see that the horizontal asymptote is at 0. That means that the k value is 0, so there is no vertical movement. So it is x minus h plus 0. According to this, we move 1 unit down, in this case 1 down, and we see that so this final graph, we have to pay attention on the function. It is it looks like it is decreasing very fast after the asymptote. So that means that the function or the base is not a positive number but a negative number. So again, let's find out the horizontal asymptote first, and that gives you an idea of the vertical movement. So the vertical asymptote is moved 3 units up. That is then a to the x minus h plus 3. According to this, we move 1 unit down now, and this is my new y-axis. So this is my x-axis, this is my y-axis. And as the function is negative, the important point or the critical point is not going to be 0, 1, but 0, negative 1. So we have 0, negative 1 at this point, and that gives you the idea of horizontal movement of 0, because it is at 0, negative 1. So the idea is that this function is not moved horizontal, is moved only vertical 3 units, and now we obtain the a by taking into account my 1 value in the new axis, and when x is 1, my value according to my new set of axes, it is going to be negative 2. So y is going to be negative 2 to the x plus 3. Okay, I hope you have understand this video. We will work on a set of exercises tomorrow. So if you can, please print the page that is called How to Recognize the Equation of an Exponential Function, which is going to be uploaded in Schoology. Thank you very much.